United States defense has a long history of developing combat technology to maintain military superiority. The United States has great strength in the development and use of advanced drone technology. Drones, or unmanned aerial vehicles, have an important role in modern military operations and provide tactical and strategic advantages. The United States Department of Defense regularly allocates budgets for research and development of military technology. The development of military drones, especially those with advanced capabilities and technology, often involves enormous costs, reaching hundreds of millions to billions of US dollars. These costs cover various aspects, including research and development, design, production, testing, and technology integration. Here are America's newest drones for now and for the future. A drone is an unmanned aircraft. Drones are more formally known as unmanned aerial vehicles or unmanned aircraft systems. A drone, in its simplest form, is a flying robot that may be remotely controlled or fly on its own utilizing software-controlled flight plans in its embedded systems, which collaborate with onboard sensors and a global positioning system. The military was most frequently linked to UAVs. Initially, they were utilized as platforms for armaments, anti-aircraft target practice, and, more controversially, information gathering. Today, drones are utilized for a variety of civilian purposes. Boeing is bringing the future of unmanned aircraft carrier aviation to the U.S. Navy with the MQ-25. Boeing said it proved in a virtual demonstration this spring that several U.S. Navy aircraft types could task the company's MQ-25 Stingray tanker drone with surveillance missions and receive live imagery in support of their own missions. Boeing won an $805 million development contract to build 4 MQ-25 carrier-based unmanned aerial tankers in 2018, prevailing over competing designs built by General Atomics in San Diego and the Northrop Grumman Corp Aeronautics Systems segment in Palmdale, California. The Boeing MQ-25 aircraft has an advanced, customized remote I/O interface controller based from ATEC Defense Systems, incorporated in Chatsworth, California. The system is based on the ATEC iRio avionics remote interface. The MQ-25 Stingray is an uncrewed aerial refueling drone that is being developed by Boeing. The Stingray can almost double the effective strike range of the U.S. carrier wing. The MQ-25 will give us the ability to extend the air wing out probably 300 or 400 miles beyond where we typically go, former Vice Admiral Mike Shoemaker told U.S. Naval Institute's proceedings. The MQ-25 will provide aircraft carrier-based refueling capability to extending the combat range of deployed F/A-18 Super Hornet, EA-18G Growler, and Lockheed Martin F-35C combat aircraft. The U.S. Navy's new MQ-25 Stingray aerial refueling drone bears an uncanny resemblance to an experimental U.S. military plane from the late 1970s. And that similarity could point to the way for the Stingray's potential evolution from a tanker into a stealthy surveillance and strike aircraft. Advanced technologies that will support the program and facilitate future missions include a deck handling device, ground control station, and communication links. MQ-25 is comprised of 2 major segments: the MQ-25 Air System, Air Vehicle, and the Unmanned Carrier Aviation Mission Control System, UNCS, the system required for carrier integration and command and control of the MQ-25 air vehicle and payload. PNA 268 manages these segments as the Government Lead Systems Integrator, LSI. The MQ-25 TIM Stingray will be the world's first operational, carrier-based unmanned aircraft and provide aerial refueling and intelligence, surveillance and reconnaissance, ISR. capabilities that enhance capability and versatility for the Carrier Air Wing (CVTOW) and Carrier Strike Group (CSG). The Navy plans for all NMITs and FORD class carriers to eventually be MQ-25 capable. MQ-25 is currently in flight test, gaining valuable early insight from the contractor-owned MQ-25 predecessor, T-1. In 2019, the government/industry team conducted its first flight with the MQ-25 T-1 test asset. Data from early T-1 testing allows for learning and discovery to advance the development of major systems and software and supports a rapid developmental test program.